Okay, so we've got a comet. I don't even think I'm going to try to pronounce the Denning, Fujikawa, maybe that's how you say it. Appears every 9 years and was last seen in 2005. So if we think of 2005 as our first one, when would you see it next? 2014. So if this is accurate, look outside today. Maybe you see it. I don't know. Maybe it's only coming at 2:15 a.m. on December 13th. I guess we could look it up. And if you really wanted to see your comet, this is the year to do it. Okay? If we miss it this year, we got to wait another 9 years. So these are very exciting things for some people. For some people, it's like, yeah, there's a little line going through the sky, but you know, it's pretty cool if it's a comet. So anyways, you keep going up. If you miss it, it's going to go to 2023, ... You've just found the fountain of life, and you say, I'm not going to worry about seeing this until like a long time from now, maybe in the year 3085. I'm going to try and see this comet. So you're wondering, will I be able to see it then? Because I'll be like just over 1,000 years old, and you know, to celebrate my 1,000th birthday, I'm going to see if I can see this comet. Yeah, like it's going to be awesome. I wonder if I'll probably have a few more gray hairs, but anyways, so we're going to find out if this comet should appear. So we're going to take this sequence, and we arbitrarily made 2005 our term 1. That's okay. We know that we're going up by 9 each time, so we know that our common difference is 9. And we can use our formula sheet and write out a formula for this sequence. We know that the general formula, Tn, is going to equal 2005 plus 9 times n minus 1. Now, if 3085 is a term in this sequence, then Tn would be 3085. That's what we're wondering. Is that true? Well, it will be true if we can solve for n and we get a whole number. Like if n is 255, then we know that term 255 is 3085. Perfect. It's in the sequence. But if while we're solving for this, we get a decimal, 255.6, well, that means it wasn't perfectly in there. It was 0.6 between two different terms, and you wouldn't see the comet at that time. So we assume that it is part of the sequence. We assume that Tn is 3085. We plug that in, and we say, if that was true, can we figure out what n is? And I'm going to distribute this right away. Plus 9n minus 9. Because that 9 out in front would get distributed. Some math here. I'm going to put the 2005 and the 9 together. Subtracting 9 off that gives me 1,900 and, whoa, easy, 96 plus 9n. And we subtract the 1996 on both sides, and we get 3085. 1,089, right? And you'll correct me if I make any mental math errors, right? And then we divide by 9, and yes! My birthday celebration will be just wonderful because it works out perfectly to a whole number. Okay? If you look at the example that was in the textbook, their solution, if you look on the next page, on page 7, they got n to be 14.907. Their example was an example that didn't work out. Yes? I took this and this as like terms, and I subtracted. Is that a mistake? 2004. Okay. Yeah, it does work. But that's because these are like terms. So I put those together. You could have subtracted the 2005 and added the 9 to the other side. That would have worked as well. Okay? So this one, it works out to a nice whole number. We know that it's part of the sequence. So you've got lots of time to see this comet. Relax. Don't stress out if you miss it this year. Yes. And the question you can do for this one as part of the homework assignment is question number 14.